Okay. Check, check. Okay, hello everyone. My name is Andrei. I'm sorry for my voice, just got screwed up this night. I'm a PhD student with Euricom in Sofia Antipolis, but excuse me, I'm just moved, so I don't know too much French. I'll be talking English. Okay, I'll be talking about Postscript today, and basically just a short who am I. I mostly started my security things with RFID and my favorite classic, and the result of this was MFAQ toolkit. Maybe some of you used. Did somebody used MFAQ toolkit? I know it's hard to use, sorry for it, but it was a proof of concept. And then I moved to hacking MFPs, and basically there were a chain of research, and Postscript basically is a natural continuation of this. And in general, I'm interested in holistic security approaches, which is idealistic world, but anyhow, we just try. You can see some of my papers or security advices. And yeah, let's go with Postscript. Just a quick question. How many of you know Postscript, wrote a simple program by themselves? Not so many people. Okay, we'll have some samples at the end. Maybe you'll find them interesting. Just to start about printers and MFPs, not sure how many of you did go through my research or for the research of other people doing printers, but the idea is that MFPs are not perceived as high potential risk devices, but one aspect which pertains to them is that they're inside your network. So basically, as you can see, they're part of the internal private network. They are not very well standardized or implemented in terms of patch management in general, right? Some of them do not support patching, some of them support, but in very awkward or insecure manners. They usually get very easily connected to public internet. You just plug them in. If your network is very permissive and your perimeter security of the network is not very well secured, your device will end up on the internet, and I'll go in a second to this. Because it's inside of your network, it's a trusted resource. As you can see, it's a very trusted resource. Imagine you go scanning a PDF on a MFP, and the PDF, because MFP is infected, it sends you a PDF with a 0 day. But if the user clicks it, because it's a trusted resource, it's part of the network, and the user is expecting to get a scanned PDF, right? So it's a trusted resource, both in terms of technical equipment and both in terms of social engineering, or you don't need a social engineering for this. And of course, it gets to print very confidential information, because sometimes just confidential information has to be printed. So all these properties make up the MFPs and printers a very good target. Okay, printer or MFP hacking is not quite new. It goes back to the 60s when US spied on Russia's or Soviet Union embassy in US, and they actually used electromechanical hacks, and there was a serviceman going every week to change, the cartridges and clean up the drums and so on. And at the same time, he was just pulling off the microfilm. You can see the camera there marked X, and that was actually the information exfiltration device. There's a whole story about this in New Scientist. However, more recent news flashes about printers. Printers were associated with physical attacks, like printers used as bombing devices, which was a little bit of a hype, but again, it's linked to a physical attack. There was some evidence, but the nature of hack or the communication to the control center was unclear and undisclosed. But there were evidence that Chamber of Commerce of US had a printer in one of their corporate centers who was communicating with China and sending, Chamber Commerce related information. And a few days back, there was a very big fuss. I'm not sure how many of you have read this or have been affected, that printers started to spill out random characters and wasting all the paper from their machines. Basically, it wasn't a Postscript or a printer virus, but all the security companies got, on their community or support pages inquiries for the printer viruses, because as a side effect, one of the malware were trying to exploit some spooler, as in Stuxnet. In the spooler subsystem, there are some vulnerabilities, so they tried to exploit the spooler vulnerabilities, and as a side effect, they just were placing some binary where those binaries were get to the printer, and so they end up with printing random garbage characters, but they're not actually a printer virus. However, you can see that in a couple of days, they were very big. If you go to the links attached, there were a lot of organizations complaining about their printers basically being attacked in a full-scale manner. And this actually shows how unsecured are those organizations in all their set of MFP and printer devices. Basically, they are not secured at all. So any side effect can lead to direct data or code upload to the printer. Some modern mentioning is digital hacking of MFPs and printers, started by FX, then completed by IronGeek, and then in 2010 it was renewed, and it actually spawned different directions, from web interface of printers being hacked, and there's various tools, and PGL as well. So basically, I went for the Postscript as a COSTIN question for my research. Why I said it, your devices or devices like MFPs and printers are made easy for the users, meaning that you connect them and they are almost instantly on the internet. So this is an old screenshot, but I keep using it because it's very visual and it gives a very good impact on the people understanding this. How serious is the problem? Just doing a Google Doc or a Shodan search basically gives you, in easy few clicks, more than 24,000 devices publicly accessible to the internet. And if you go to that video, you'll get 2 minutes of very nice information about these devices spread all over the world and about their versions and so on and so on. So basically, various ways to reach. For example, if they are not connected to the internet to upload your malicious code, supposedly, there are ways to put the malicious code in either Word documents or in Java applets, and those channels can be used to reach devices which are not publicly accessible through the internet. Okay, so I hope this refresher gives you a quite big picture. What is about MFPs, how easy they are accessible, what are the channels to bring your attacker's payload to an MFP or a device. So having a way to deliver a payload, either by directly contacting the MFP or the device, or sending a specific URL with Java applet, or sending a specific document to the target, is a good way to deliver the payload. But now we want to focus on the payload. And one of the natural things to look for the payloads is to see what languages or data formats does the printing industry use. So basically they use two big standards. It is either Postscript or PCL. PCL is a data format only. However, Postscript and PCL comes from HP. Postscript comes from Adobe, and it's basically a very old programming language. It is very important to note it's a programming language, and basically the document which is being sent to the printer is not a static document. It's a program, right, which is being run in a virtual sandbox environment of a MFP. So think of printers as hosting a small Java-like virtual machine, right, which is Postscript sandbox and interprets the documents over there. So this picture is taken from a manual of Adobe, and it is very representative because there are all these is bumpy, and of PostScript is bumpy. I see it as this way. The road is bumpy and have unexpected turns because being a programming language, Turing complete, you can do a lot of stuff in it, as I'll go through the slide. So basically, people have been using PostScript to build complex math operation because it's oriented towards graphics, and naturally it has very powerful graphic operators like matrices and so on, which can be used for various complex mathematics stuff, and it can be also used for very complex computations like rainbow calculations or hash cracking or so on and so on. Some people even create web servers, ray tracing in OpenGL. So basically you have a program or you have something to render, and you can actually render the image on the printer, and you get a very nice ray tracing engine in PostScript, which is a fantastic and tremendous job. You don't need those expensive and specialized software like 3D Studio Max and Maya and so on. Okay, so as I said, PostScript is not a static data format. It's a programming language, and basically some of the characteristics which are important to PostScript is that it is a dynamically typed and concatenative. It is text-based. It is Turing complete programming language. And you might be wondering, what the hell are all these terms? And to basically Turing complete, one of the characteristics of Turing completeness is that if you have a language, a specific language, let's say C or whatever, PHP, and there is a general purpose computation, you can take and do a transform which makes from that language into PostScript. So basically, PostScript can be the endpoint of any transformation for general purpose operations. I mean, of course, if the language uses very specific hardware instructions, which are not available in PostScript, then it will not work. But for general purpose, like doing computations and various stuff, Turing completeness helps PostScript. So it is a endpoint for transformation. Now I'll go to the dynamically typed and concatenative aspect later. And stack-based means that basically all the parameters for the functions and so on are passed in a local stack. Basically, PostScript environment has a virtual stack, so to speak. So all the parameters are passed on stacks. So all the functions have to be designed with a mindset that there is some object or some primitive data type on the stack itself, right? Okay, so just a very quick overview. What generally happens when a user prints or opens a PostScript file? For example, if a user just have a word processor, right, or has a graphical MS Paint tool, and he hits the print button. What happens is the operating system sees what kind of a driver it is installed, and if it's a PostScript driver, it gets the data from what you see is what you get format to the driver. The driver being PostScript, it transforms that data in a PostScript program, and the result of that program being interpreted on the device is the actual representation of what is on the screen of the user, right? The same happens when a user opens a PostScript file. For example, he has a PostScript file sent to him. He opens. There's a local software, which is a local software implementation of a PostScript interpreter, not in the printer, but on the PC. Usually it's GhostScript. I think everybody used at least once GhostScript to open those kind of files. It opens and renders the files, and once you hit print, again, the data from the screen or from the file, which is being rendered, is being passed to the printer driver. The printer driver makes a kind of reinterpretation of the data, creates a new or the same or reuses the program and sends to the printer. Now, the way it sends to the printer is either via the USB cable or the network cable, which is basically the physical medium for which the payload is delivered. But the payload is, at the end of the day, a full PostScript command. Now, the idea is that if it's a program, right, I mean, you can do a lot of stuff, and everybody who did the basic programming knows that if you have a programming language, you have if, else, loops, and so on. And basically, the most basic denial of service is just make an infinite loop. Okay? And just to demonstrate this is, as somebody put in a write-up, very nice, like a denial of service in less than 10 characters in Postscript. So basically, at the bottom you see the program. It's a full Postscript program, and it will do a denial of service in Postscript interpreter, be it software or hardware-based on the printer. On the printer, of course, you can go and hit the cancel button, and if it's implemented properly, it will exit the denial of service state. If it's not implemented properly, the printer will have to be switched off and on to be rebooted and reload its Postscript environment. So just to demonstrate this, I suppose not many of you knew that even your Office distribution have a Postscript software Postscript interpreter in it, but it's very well hidden. You cannot actually reach so easy. And how you usually invoke it's like this. So we have a EPS picture. You know, EPS, it's encapsulated Postscript. It's kind of a picture. And why it's EPS? It's basically, they figure out that some of the servers, computers, do not have the power or money for licensing the Postscript interpreter to be implemented. So they said, okay, let's do another format, which is encapsulated Postscript. And what it means that EPS is a dual format. It has the full, it can have, of course, it can have the full Postscript program to represent its graphics, so to speak, but it also has a kind of a binary thumbnail. So if a software needs to open an EPS image and it doesn't have a Postscript interpreter inside it, it just reads the thumbnail and displays the thumbnail because it's binary. It's already interpreted. Of course, you can see a lot of problems like, what if this section is missing? What if the thumbnail represents a 0, but the program actually displays 1? All these things are very, tricky, so it's not easy, but I'll just show you, I'll get to the point of that later, is what you see and what you print. There will be a demo about this. So I just insert a picture, which will be the simplest DOS, and just to show you that this simplest DOS, excuse me, is, okay, there are some comments which I put, but at the end of the day, it can be as simple as this presentation, right? So it specifies a EPS format, version 3, whatever, it doesn't matter. You can just put something like this. And okay, opening this to Microsoft Word, it will start interpreting it, okay? So it hits the loop. And the loop is there, like it's infinite. And it never exits. I mean, I'm clicking, but because the way the interpreter is incorporated into the MS Office package is in the way that it's not multi-threaded or, very well programmed. So it's just stuck in there, and okay, let's hope for the best. Now, just have to kill it because otherwise it just doesn't get it. Okay. It's very nice. It always asks me to send the sample. Okay. I sent them one day. They said it's not a security issue. Okay. Now the idea is that let's do a simple IDS IPS rule which would detect these files automatically. But as I said, it's this characteristic which is called dynamically typed concatenative. It means that you can concatenate various things in Postscript, and then dynamically type means that whatever you concatenate, you say, now it's an apple, now it's a pear, now it's an elephant. Please interpret it, right? So you give a dynamic type on the fly to it. And basically, your IDS and IPS looking for this kind of things will not work at all, because of course people will come and start writing bad Postscript programs which are obfuscated or dynamically constructed. And what do I mean by this is, I'll just show you the sample. Okay. We have a concatenate string or merge string. These are two helper functions, which are not important now. And we have the simplest DOS statement I had in previous example. These characters, the percentage characters, means it's a comment. This thing is dropped, is not interpreted, right? So basically, you see all of these are comments, and this is like a magic hashbang, right? Like the hashbang in shell. Okay, so this is not interpreted. I could have just deleted. Now, the parenthesis means whatever is inside parentheses is a string, right? And when I define a constant or a variable, it goes on the stack. So what does this line of code? What means it puts 1, 2, 6 strings on the stack. Each string consisting of one character. This one, then this one, then this one, and so on, right? And you can see that the characters here are the characters which form this, right? It's easy to see. Everybody see them? Okay. So then what it does is just it goes, looks if there's more than one string on the stack, it says merge the two things on the stack until it merges everything. And it gets one string, right? So we use the concatenative thing of the Postscript. So you have one stack, one string on the stack. Now it's a string, right? So here comes the dynamically typed, where you say convert it to executable. And what it means that whatever was on the stack will be made executable in the terms of Postscript. So this Postscript will say, this command is executable, let's execute it. Okay? And then we say, execute it, please. And it will execute. So the demo is, again, simple. Okay, dynamic statement, okay. And the result is the same, because we constructed dynamically and dynamically typed the string to be executable. So you can see that IDS and IPS will not work. Only a dynamic interpretation environment would work on real Postscript stream. And this is applicable to IFA files, which you get by mail to open in GhostScript or whatever, or in pictures like EPS. But this is true also for the stream, which goes from your printer, from your PC or your print server to the printer. It is the same, because on the network, the same kind of programs are traveling, right? Just more complex and so on. So I hope it gives you a very clear picture of what Postscript can do in very general term. So as I said, the bad news is you need a dynamic execution sandbox, which is not there on printers, they're not there on print servers, it's not there on your PCs. And basically, as part of my academic exercise, I'm currently building it just as an academic result. Okay. The other thing is, because it's a programming language, you can format documents on the fly, right? I mean, you can say, well, let me see. If I can fingerprint your environment, and which I can do, I can say, you display me on your screen, you are running me in GhostScript, okay, let me show you that you'll pay me 100 euro, right? But when it prints, I can say, I'm running now in the printer. Let me print for this sucker 10,000 or 1,000 euro. And basically, to be frank, how many of you basically take a document, go through all 1,000 pages, hit print, and go and read again those printed pages? How many of you do this? None of them, right? So you basically take and sign, correct? This is what you usually do with your documents. And this is a very powerful example for mostly management and business people, because technical people understand the loop example, but business people understand this kind of examples where you have what you see is not the same what you print, and only because it's a programming language, right? So you see the consequences. And another thing is just an example of documents, but you can do things like, here's your Postscript document, and it can use social engineering. So when the user opens it, the document detects it's running on a PC and displays an image saying that Windows or whatever operating system is detected, Windows, Linux, has detected the error in printer driver. Please send this file for printing directly on the printer. So usually on the network printers, you have the ability to go to the web interface, and in a web interface, there's an upload for printing functionality. How many of you did use this or know about this? So basically, on the web interface, there's an upload, you upload the file, and the printer takes it through its web interface and it prints. So you can do a document in Postscript which shows this kind of social engineering, a screenshot, and says, I cannot display this document to you because it's something broken on your PC. Please print it directly to the printer, right? And on the printer side, it has the else statement where it has the malicious thing, because some of the things which run maliciously on the printer will not run the same maliciously on user PC. And basically, our target is to own the printer, not the user PC. Even though the user PC would be sweet to have or to own, the target is to own the printer, because it's a very, low-profile device. Not many think it can be infected. If it's infected, not very easy to clean. Again, patching, not very well patching developed mechanisms. So I have put into perspective where are the various levels. So basically, at the basic level, you have the specification from Adobe. Then you have the implementation of those specifications, and the result of the implementation of the specification is the Postscript interpreter itself, which is the COSTIN, which runs on mostly PC environments or computer environments. You have the Access Software, which is a subcontractor for Microsoft, and you saw it's from old software. Adobe has its own implementation, and basically for the printer or MFP devices, there are various embedded development companies which implement or port some software to the printer. So basically, those printers have the Postscript environment. Now, on the role-wise, here was the kind of a vendor. Okay, so, and on top of this, there are modules which use the interpreter, or meaning where the interpreter is being found. And you can see that CAPS is using some sort of GoScript variation. GIMP is, if you want to open Postscript or EPS images in GIMP, it uses GoScript. Irfan View, LaTeX, and so on. For Access Software, it's Office who uses, and so on. Role-wise, you can find the Postscript implementation or Postscript user application on the clients in form of GoScript, so on. The CAPS you usually find on print server, be it a standalone device or be it a specialized server. And basically, Adobe or other embedded development companies, you find the implementations on the printers directly. Okay, so as you can see, this was a very general topic of getting you the perspective on Postscript. And the next step, basically, the step was a little bit reversed, but the next step, once you see the security implication of Postscript, is, okay, now show me a real attack. I mean, show me a real device which you can own. So the next thing is, logically, you want to find some device which uses Postscript and has some, hidden features. We all love hidden features. So going through the documentation is a very useful exercise, and I recommend it to anyone doing a device. Just go through the documentation, search for, for some terms which you are interested in. If you open some documentation from Xerox, it says that, as you can see, the figure says, select the firmware update file and press the green button to send it. And on top, it has the firmware update file will have a file extension of .ps. Doesn't it raise a question? I mean, how the hell a .ps, a Postscript file, which usually you open and see some, images and text, has a firmware upgrade in it, right? Doesn't it raise questions? It raises a lot of questions. So there's something which interacts with hardware or software or everything in that printer in order to upgrade the device, right? So there is some custom extension Xerox might have been. So the first thing is you just download that you down, and this is actually the interface which I was talking, but you can go to the web interface and upload you see, a PDF, a TXT, you can upload a file for normal printing. And exactly the same interface and the same mechanism is used to upload the firmware upgrade file. Isn't this like a shortcut in development process? Like, okay, we have a functionality to print, but okay, let's put some functionality which through the same window and same processing mechanism will upgrade the firmware. It's just not right it saves development cost, of course, but security-wise, it's not right. It's not correct. And the first thing you do in this case is just download the firmware, try to unpack it, reverse engineer, and so on. So we found various categories of APIs. You can see there's a lot of categories. Some of them we didn't even map. The most interesting is VxWorks API, debugging, and of course the lowest layer, which is RAM disk, and flash. Because if you own the RAM, meaning reading and writing, it's everything you need, right? I mean, you can patch the instruction in the memory, you can read all the things from the memory. So you always go for the cheapest choice in terms of effort. So we took the memory dumping approach, and again, as one security institute named SANS, they say that emerging security threat, one of the threats which will be valid from their perspective in 2012, 2013, is memory scraping will become more common. Meaning, the attackers will go, just if they found a way to get your memory, be it extension through custom extension, through some exploit, they'll go that way. They'll not find a way to compile VxWorks file which works for a specific platform, maybe it not work. They'll go directly for the memory. This is the most straightforward approach. So what we found is that if the administrator just goes, okay, the first thing which people secure in their routers or printers is they go to the administrative interface and set the password, right? And they are secure suddenly, okay? But the idea is that setting a password for the web interface doesn't and didn't in this case, and I'm sure in 99% of other cases, just setting the password on a web interface doesn't secure the device in general, which is, again, a common mistake in thinking security-wise from both policymakers and because policymaker says, just set the password on this device. And administrator also, I've set my device, I've checked the box. But security-wise, it's not a good thing because these were like two different modules, and setting the password didn't help prevent us to send a print job with specific Postscript commands to dump the memory. So the device was looking secure. It pops up the password, but we could still print to the device, and our print stream, which goes to the device, was containing malicious programs, which I'll show in a second. Another thing is we found, going through the memory, mapping the area, is another thing which might seem as a small mistake. What is the difference between using a get and a post, right? It's not much difference, and it's a printer. But in the get, you get all the parameters in the URL. And what they did is they implemented the password setup, or password change. When an admin goes to the web interface and puts his password, the parameters to the change password form are passed in URL. And as you might have guessed, the URL accessed were found in the memory. Because we're going in the memory, we found the URL which were requested, right? And the URL contains all the passwords. So again, a very, very simple mistake, but if those fields or those parameters would have been passed as post, it would have been less chances that the attacker find the post parameters in the URL logs. It's almost impossible. So maybe they find another memory area where they store, but in general, we didn't find the post parameters area. We found just the URLs and everything was there. And they were clear text, of course. Another thing, again, going through the memory is that they also stored the headers for some reason in the logs and for their own reason, I don't know. And of course, the password is set up, this is fine. Admin logs in, and he thinks he is secure, he changes his password. Every time he logs in, the basic authentication dialog was there, and we extracted the base 64 representation of the user password. So again, it's a game over just sending a malicious printing document and getting all that password echo back on the communication channel. Okay. Now, I'll go to the demos in a very short. Okay, so these things apply to plain HTTP, and there are people who strongly believe that just enable HTTPS and all your problems with HTTP is solved. They're like, again, implementation mistakes, like the private key being in memory. I mean, if you go through the memory, you don't even need privilege access to the file system, because at a point in time, this key is being loaded and is stored in the memory, and that memory is not being protected in any way. So you can get the key, right? And again, it's a game over. It's just a matter of a slightly more effort from the attacker to implement the decryption. I mean, it doesn't change anything in the effort of the attacker. I mean, substantially. It changes just a few days, a week in the effort, but substantially doesn't check. And using the default keys found as example on the internet is also just do not use the defaults from the internet for setting up the derivation keys and so on. So HTTPS, again, HTTPS didn't provide the necessary protection because the implementation was faulty and leaky. Another thing is that to a certain extent, and maybe it's not part of the Xerox fault, maybe it's part of the Postscript implementator's fault or Postscript vendor fault, is whatever document is being, I mean, not malicious, a valid document. Let's say somebody is printing the payroll, the HR payroll, right? All the documents are sent usually in clear text over the wire. Let's say you are very secure and you implement HTTPS and your network is very secure, so Wireshark fails. And also you take the precaution of, let's say, encrypting the document on PC. You buy very expensive software plus hardware plugins for the printer, and everything is secured, even starting from is doubly encrypted. First in the computer, which prints, then on the wire, because you set up HTTPS. But at the end of the day, it has to be decrypted, right, to be able to print it. So all the decrypted things, again, were in the memory. Going through the memory, we mapped an area where all the raw document to be printed is there. So you just monitor that area constantly and keep pulling it, keep pulling it, keep pulling it. And you get very interesting documents. You also get those streams, which come from the driver to the printer. They also sometimes contain passwords, which users set to secure their printers, because there are printers where you can put a password or a PIN code so that the paper doesn't print immediately. You have to walk to the printer, enter your password or PIN, or swipe your card, and then it prints. This measure was introduced so that people cannot take other people's document while they walk, right? But these passwords and PINs were also found in the memory, so you can learn a lot about that person. Maybe they reuse their PINs, maybe they reuse their passwords, and you get much deeper implications of just to know it's a simple document. And another thing is that when you connect a network, MFP or printer to the network, usually as a normal intelligent device, it tries to see who are its neighbors or devices, what is the topology, to know how to interact with those devices. So basically, it does a network scan, kind of, you know? Think of Nmap, kind of, to a certain level. So it stores all the results in memory. So the attacker, without doing any scan, can get all the topology of the network just by taking from the memory. So this is the memory dumper running. It dumps a lot of memory. Okay. this memory gets back to ourselves. It could be analyzed directly in the memory by the Postscript program. Just for the sake of demo, we copy it in a document, and as you can see, basically on my network, I have a router on my network which I tested. I had the router, and in memory of the printer, there was exact address and all the details of the router which was there, and I also had. Yeah, you have the server version and so on and so on. Okay, I also had an HP. Okay, just 1 second. See, this is my router, which was a D-Link. So I know it's a D-Link. I have its server versions and kernel and so on. I also had another HP printer on the network. I know the model as a normal user, but the attacker also has knowledge about its IP, its type, right? I mean, it's a Hewlett-Packard model, exact model. What it means is that, what it means is that the attacker can just do a quick specific memory dump from your printer and know exactly the topology. And having the exact string of the server, it can have a table of exploits, right? I mean, I know it's Linux version this and this, fire this exploit, just blindly, okay? And you have everything like spreading in a blink of a second, because it's a programming language. It can do if, very simply, if this, fire this binary code just, blindly. And to help us fire this code, there are like sockets, outbound connections from the printer. You basically run a program on a Postscript program on the printer, on the Xerox, and it can do two-way, full BSD style sockets all the way you need it. So just very quick example. Okay. Sorry. No, not this one. Sorry. Okay, so you can see that the printer IP is 102, and that the attacker IP is 101. And now, basically, I start the Wireshark, let's say on attacker's end. Okay. I show that from attacker, I can reach the printer, which is 102. You can see the attacker, 101, pings 102. In this window, you see the telnet to the printer IP. Okay? And why I'm doing this telnet? Because what happens, the printer driver, when it sends the data to the printer, it actually does this. It connects to the TCP port 9100 of the printer, and it dumps the print stream. The print stream can be PCL or Postscript. Okay, so I'll just a little bit hurry up, sorry. Okay, so as you can see, I have this socket outbound connection. I'm dumping the data here. You see the data, and you can see that. Just 1 second. That 102, which is the printer, like goes to 101 with, let's say, ping request, and my host is going back with ping reply, and it can do whatever the stuff you need, right? So there's a lot of stuff you can do from the printer. You can exfiltrate data using ICMP, DNS, whatever the latest and coolest techniques people are developing for the PCs. You can just port them and throw them into Postscript. Okay, so this was the two-way BSD style. So basically, this is a summary matrix. I'll just have 3 minutes, I think. These are the models which are affected. Xerox is trying to fix things. They're being very open and, let's say, active, but it seems it takes some time. So I'll be releasing some code that you or people who you know can use for testing only for your own printers. But the full patches, it seems that Xerox will be, the full patch, they started releasing patches, but the full patches will be in October 2012 for some reason. They were okay to release some pen test proof of concept. So it's the source code demo time, which I'll be putting also on my site as well. Okay, so I'll be just very quick. We have the memory dumper, we have the sockets, and we have the VxWorks command. So I hope you guys will like it and will use it and improve it. So okay, VxWorks command, they just work like this. It's like you put the command on the stack, you put the parameter, simple, right? As in, and you say, find me this resource, and the APIs which I was mentioning is Vx, coming from VxWorks, is procedure call, and then you do exec. So basically, it fetches the procedure from the memory, okay? It looks for this procedure, it finds in the libraries or executables, it passes this parameter, it does the stuff. And so with most VxWorks command, time, print working directories, devices, and so on. Normally, in normal distribution, you also have TFTP, so you can directly not write your full socket program, just use TFTP to exfiltrate data. So this is one. The sockets are kind of the same. You just, analogous to this is socket file descriptor, which calls the socket function with this AFINET and SOCStream parameters. So we put the AFINET and SOCStream as parameters, 2 and 1 and 0, and we call the socket function, and we say to this VxWorks, please execute this function and return us the socket file descriptor, and it will return, okay? Then you just say, okay, please call us the connect with this socket. Yeah, the magic word is like this, exec, VxProx, please. And then, of course, you do the cleanup to stay alive, close, and socket descriptor is pretty simple. I mean, sometimes the language is not very, easy to jump from C directly to Postscript, but you can see the analogy. If you learn the pattern, you don't need to be an expert in Postscript just to, at least monkeying the code from here to there and just play with it. You can do patterns like this. And the memory dumper is, we have address to start mapping or dumping. We have address stop. We say, we put the address on the stack and say for this address, okay, we check with dup means duplicate on the stack. It's, you have to read a little bit of documentation. Check if it's greater than address to stop. If it's greater or equal, we exit the dumping loop. Otherwise, we just continue. We use the hex format, okay, and print the hex prefix. Then we doubles for the 0, which for the characters from 1 to 15, it's 1 character. We have to put a 0 in front. And basically we print and merge the strings and just print all the stuff which you saw running in the console. Okay? And very quick closing remarks. I'm sorry. 2 more minutes and I'm done. So basically, remote attacks are like the attacker sends Word document, Ajax, Java applet. It can be also JavaScript. The JavaScript thing was found in 2009, but wasn't exploited very much, but it's a powerful attack. Sends to the user in forms of social engineering. Here's a coupon, here's your, free money, whatever. He prints the attachment from the document or from the web. The attachment has malicious data for the printer. It gets merged into the print data which is sent to the printer. Printer is being owned, as I showed you with any socket or memory dumping. And then the printer can operate in stealth or malicious mode and start, as I said, using the passive network scan dump to spread to other devices, given that the payload contains a table with exploits and corresponding exploit for each version, and just blindly, throw at them. The solution, it's normally people shouldn't have access to the printers directly, and normally I'm happy to see organization actually implementing these solutions, and I'm happy that it's partly one of the things which my and my other friends who did printer research persuade them to do, meaning that we actually convinced by the demos that they have to do something like this, have a print server which is in both VLANs. Computers do not have access to the printers. Everything passes through the print server. Of course, you have to have a very iron-strong print server, meaning that it's not exploitable, and you hope there is no exploit for the drivers, and so on, but at least you have one point of failure, not 1,000 printers' point of failures. And all the print jobs go through the print server. Again, on the print server, what is missing now, and what I'm working on, is the Postscript and print stream sandbox environment, which dynamically takes and analyzes for security threats the streams, and if it finds anything suspicious, it can alert or drop the print stream entirely so that it doesn't reach the printers. Okay, you can, if you want, subscribe to this, where the code will, the proof of concept code will be available, and updates on the sandbox environment. Okay, other thoughts would be like integrating with Metasploit or porting from Metasploit to Postscript and have two parallel engines there and there. Okay, some acknowledgements. The Xerox staff was very well supported by Security Research Labs, and I'd like to thank them. Very nice and very professional guys. And I would like to thank Eurocom for support on this research. And yeah, if you have questions, I don't know for sure we have questions now, but you can reach me after offline the conference or by mail. I'll be glad to answer your questions or share ideas. And yeah, my papers are online, previous and present, so feel free. And the videos are on YouTube. You can see really cool stuff with the map. Thank you very much for attention and for being with me.